Hello, everybody. In this video, we are going to go over the solutions to problems 24 to 36 from the Algebra 2A summer packet. These are kind of your basic algebra skills that you should have first learned in Algebra 1, but then certainly had a lot of practice with last year in geometry. So they are very important, and of course, you can watch the video as many times as you might like. To start you off, I have a couple of problems here just to remind us of the magic word, which is, of course, to FOIL. You would use this technique anytime you're being asked to multiply two binomials times each other, which means, of course, if you have two terms in the first set and then two terms in the second set. So if you're going to multiply, the FOIL, of course, tells you how to multiply the first, the outers, the inners, and the last. Here in this first example, when you multiply 3x times 4x, 3 times 4 is 12, x times x, you would add those exponents to get x squared. Then for the outers, you would multiply the 3x times the negative 3. Don't forget the sign, and that's going to give you a negative 3x. For your inners, positive 5 times positive 4x is, of course, a positive 20x. And last but not least, when you go to do the last, a positive times a negative, in this case, is a negative 15. You will then combine like terms. When you combine like terms, you should always put your answer in, of course, what's called standard form, which means you go from the highest exponent down to the smallest exponent. And then here with the colors, you have a second example. So again, review the FOIL technique as needed. Here are the problems from your summer packet. So if you go ahead and employ that technique, c times c is, of course, going to give you c squared. That's your first. Then your outers, negative 3c. Your inners, negative 5c. And then your last, make sure that you do a negative times a negative, which is, of course, a positive. For your final answer, standard form, so c squared to start, combine like terms in the middle, and positive 15 at the end. Similarly here in the next problem, so 2a times 7a, that's going to give you 14a squared. When you go to do your outers, negative 8a. When you go to do your inners, 49a, and when you go to do your last, negative 28. Standard form for your answer, always, they call it the standard form because everybody's answer will look the same. So 14a squared, combine the like terms in the middle, that's going to give you a positive 41a, and then finish it off with a negative 28. Now, typically, most people's variable is, of course, x, and that's the one that you're going to see most of the time, but you do have to get used to using different kinds of variables, so make sure that you do that. Finally, for problem number 26 here, whenever you see a problem like this, meaning that they have the same front, the same back, but the opposite middles, those are, of course, called a pair of conjugates. The beautiful thing about multiplying a pair of conjugates is that when you do the FOIL, the outers and the inners will always cancel out. If you're able to kind of see that right from the start, you can skip a step. If not, do the whole thing. And of course, the outers and the inners in this case will always cancel. So 2x times 2x, that's going to give you a 4x squared. An outer is going to give you a negative 2x, followed by a positive 2x for the inner, and then a negative 1 to end it. Again, because these are a pair of conjugates, same front, same back, opposite middle, the outers and the inners are always going to cancel each other, giving you a final answer of 4x squared minus 1. This is also called the difference of squares. So again, if you see that as a shortcut, you can skip the outers and the inners. If you do the whole thing, it takes a couple of extra seconds, but you can rest assured that they will always cancel in the middle. Factoring is something you've been doing for years and years and years. It's never going to go away. So the sooner that you get used to the different kinds of factoring, the better off you're going to be. This is a reminder of how you would factor a trinomial, and this is how you would factor a trinomial that has a coefficient of 1, meaning that in front of the x squared, there's only a 1. So in a case like this, you're going to go ahead and start by writing two sets of parentheses. Whatever the variable is, you're going to put one of them in the front of the first parentheses and one of them in the first of the second parentheses. Then to fill out the parentheses, you're looking for two numbers that multiply to be the last term and add to be the middle term. So 24, if you went ahead and made a list of some factors, you would hopefully land on 6 and 4 as being the ones that multiply to be 24 and then can combine to make a 10. Last but not least, you have to make sure that the signs, positive or negative, work out. So if you're going to multiply to be a positive 24 and add to be a positive 10, then both of those values have to be positive 6 and positive 4, and that's your final answer down at the bottom. If you want to check that you did the problem right, you go ahead and employ the FOIL technique from the previous slide, and that will show you that your answer, when multiplied, should of course become the original problem. Another review here of factoring. So this is, again, another trinomial with a coefficient of 1. So again, you're going to start by writing two sets of parentheses, x and x. You're looking for two numbers that multiply to be the last term, but add up to be the middle term. So if you look at some factors of 24, again, it's the same 24 from the previous slide, but obviously we can't use 4 and 6 because that makes 10, not 11. If you go ahead and look, you're going to get 3 and 8. Because they have to multiply to be a positive, but add up to be a negative, the only way that can work is if they are both negative. And again, spoiler alert, if you want to test to see that you have the right answer, go ahead and FOIL the problem, and you should get the original one. This is an example of how you would factor by something called grouping. So grouping is what you would use when you have 4 terms, 1, 2, 3, 4. Compare that to the previous slides where there were only 3. The point of grouping is that you are looking to group stuff. So generally speaking, you group the first 2 terms, you group the second 2 terms, you factor the greatest common factor out of each pair. So the greatest common factor of x cubed minus 2x squared is an x squared. If you factor an x squared out of an x cubed, you're left with an x. If you factor an x squared away from a negative 2x squared, you're left with a negative 2. Factor a 5 out of each of these. How do you know that you're doing this problem right? Well, you should in fact get this repeat factor. If you don't get a repeat factor, then one of two things is happening. Either you're making a mistake or the problem is not factorable. So because I did get that repeat factor, I'm going to go ahead and put that out front. And then whatever I pulled out of each combines to make my second term. So again, this is how you would factor by grouping. And that's the technique that we're going to need here in problem number 27. So again, you're going to go ahead and group the first 2 and group the second 2. The greatest common factor of these first 2 terms is a b squared. And when you take that out, you're going to get b minus 3. Sadly, b and negative 3 don't have anything in common aside from a positive 1. So you are going to factor out a positive 1. You do always have to take out something. And that's going to leave you with a b minus 3. Notice we did get that repeat factor. That means we're on the right track. That means that's going to be the first part of my answer. And whatever I factored out as my GCF, that is going to be the second part of my answer. Here in the next problem, 28, a little bit of a curveball with the negative. Generally speaking, we do not like negatives to be in our factors. So you have a couple of different options. My personal recommendation would be to take that negative and just factor it out of each of the terms. A lot of the techniques that I'm going to show you really only work if the first term is positive. So if it's not negative, if it's not positive, it makes sense to go ahead and factor that negative out. So that's what I did. So then notice that I have a trinomial 3 terms with a 1 now in front of the n squared. So using the technique from a few slides ago, I'm going to go ahead and do 2 sets of parentheses. Choose the variable n and n. I need 2 numbers that multiply to be the last term and add up to be the middle term. So some factors of 20, 1 and 20, that's not going to work. 2 and 10, that's not going to work. 4 and 5, that does seem to work. So I'm going to choose 4 and 5. If they have to multiply to be a negative and add up to be a negative, that means one of them has to be negative and one of them has to be positive. And the only way that I can get that exact right answer is if the negative 5 and positive 4, because those will multiply to be negative 20 and add up to be negative 1. The last factoring technique, the dreaded one, this is of course called the AC method. So here's a problem that's already done for you and it kind of explains all the steps. The reason why they call it the AC method is because the A is the coefficient out front, the C is the coefficient in the back, and you start by multiplying those two things. So 2x squared times 12, that is going to give you a 24x squared. You're then going to take that 24x squared and you're going to try to break it up into 2 factors that multiply to be negative 24x squared, but add up to be positive 11x. So think about the factors of 24. Again, we've seen that 24 a couple of times now. So it turns out that the factors we want this time are 8 and 3. So you're going to keep the A, you're going to keep the C, and you're going to break up that 11x into an 8x and a 3x. Once you've done that, you're now going to use the grouping technique from the previous slide. So group the first 2 terms, take the GCF out. Group the second 2 terms, take the GCF out. Again, you should be getting that repeat factor of x plus 4. If you do, that's the first part of your answer, and whatever was left on the outside, that's the second part of your answer. I actually think this problem in particular really kind of goes through the steps really, really nicely. If you want to see another one, let's go ahead and take a look here at the next problem, number 29. So go ahead and start by multiplying 2x squared times 21. Now, I personally write it without the variables, although you can write the variables if that helps you. So 2 times 21 is 42. You're then looking for factors of 42 that add up to be negative 17. Now, 42 is probably a number that you're not super familiar with, but turns out that 14 and 3 are the numbers in question. And again, you kind of have to do a little bit of guessing and checking. The only possible way that you can multiply to be a positive 42 but add up to be a negative 17 is going to be if both of those numbers are negative. Remember, the whole point of why we're doing this is we want to split up that negative 17x. So carry the 2x squared, leave the 21 in the back, take the negative 14 and rewrite it as negative 14x. Take the negative 3 and write it as negative 3x. Remember, you're not changing the problem. All you're doing is rewriting 17 as 14 and 3. That's totally legal. Group the first two terms. Group the second two terms. Take out the GCF, which is 2x. Here, negative 3x plus 21. What I always like to say is when in doubt, take the negative out. So should you take out a 3 or a negative 3? Again, generally speaking, when in doubt, take the negative out. So I'm going to take out a negative 3, which is going to leave me with a positive x. And if I take a negative 3 away from a positive 21, I'm going to get a negative 7. That's exactly what I'm hoping for here, getting that repeat factor. And then, of course, whatever is left goes on the outside. Again, can't stress this enough. If you want to check your answers, which is a great thing to do with this virtual learning, FOIL, 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 and you should, of course, always get back to the original answer. Biggest mistake that we see people make, the difference between factoring something versus solving something. So factoring means it should have parentheses. Solving something means we actually want to know what is x going to be equal to. So here are a couple of reminders of the different ways that you could be solving for something. So here in the first example, this is an example of how you would solve using square roots. You're going to do this when there's no x terms in your problems. So let's say that you had x squared minus 1 equals 24. You would start by getting the variable by itself by adding 1 to both sides. Because there's no linear term, no x term, to get rid of a square, you would, of course, take the square root. What you do to one side, you must do to the other. Hopefully you remember from your Algebra 1 days, when you take the square root, you have to do a plus or minus, which means your answers are either positive 5 or negative 5. And you can write it either way. You can either write it with a plus or minus, or you can write it as two separate answers. Again, another common mistake people make. So in this example here, because there was a variable, that means that there are two answers, plus or minus. Compare that to if I just said to you, what's the square root of 25? If I just say to you, what's the square root of 25, and there are no variables, then you only have one answer, which is 5. So don't get it twisted. Two answers if there's a variable in the problem, only one answer if there is not. All right, so then here in the top right, this is showing you that technique of x and x, two numbers that multiply to be the back and add up to be the middle. Then, because this problem is equal to 0, you go ahead and set each parentheses equal to 0, and then solve for x. This is an example using the AC method. So assuming we did the process on the previous slide, if it was equal to 0, set each parentheses equal to 0, and again, solve. Most importantly, when you're using either of these two techniques, it has to be equal to 0. A problem equal to anything other than 0 does not work. That's called the 0 product property. There is no 5 product property, no 10 product property. It's 0, and that's it. This is an example of using the quadratic formula. This method works all the time, and you would have to use it if the problem does not factor. Again, when it comes to the quadratic formula, you have to be equal to 0. This is a reminder of what the quadratic formula actually is. Your first coefficient is always A, B, C. Plug the numbers in where they go exactly, ensuring that you use parentheses for anything that's squared. Then calculate what's under the radical. In this case is 25. Square root of 25 is 5. Separate this into two answers. Simplify, and you're good to go. So in the next couple of problems, you're being asked to solve. Looks like I might have skipped a couple problems there. Sorry about that. I'll add those in at the end. So it looks like we jumped right to number 32. So in number 32 here, you're being asked to solve for x. Notice that there is no x term, but only a squared. So you're going to start by dividing both sides by -3. That's going to give you x squared is equal to, when you do -54 divided by -3, that's going to give you 18. The way that you get rid of a squared is by taking a square root. Again, when you take a square root, you're doing plus or minus. The square root of 18 has to be simplified. So the biggest perfect square in 18 is 9, which goes in twice, which means your final answer, simplify the square root of 9, gives you plus or minus 3 radical 2. X squared minus 8 plus 7 equals 0. You're going to go ahead and set up your two sets of parentheses, x and x. Factors of 7 that add up to be 8, well, that's going to be 1 and 7. The only way that they could multiply to be a positive but add up to be a negative is if they're both negative, which means you set x minus 7 equal to 0, x minus 1 equal to 0, add to each side, which is going to give you answers of positive 7 and positive 1. Adding in the problems that I missed here, so going back for a second to number 30, notice that in number 30, the problem is wonderful because it's already factored for you. So -2x, 3x plus 1, x minus 8, and x plus 2. Because this problem is already factored for you, it means that to find each of your answers, all you have to do is set each of these parentheses equal to 0 and then solve it. So if you set -2x equal to 0 and solve, you're going to get an answer of x equals 0. If you set 3x plus 1 equal to 0 and solve, you're going to get an answer of -1/3, positive 8, and -2. Notice in a problem like this, because there were 4 variables, you should have 4 different answers. Again, whenever the problem is already factored, don't multiply it back out. You prefer it to be factored. That way you can just set each parentheses equal to 0 and then solve. All right, -3x squared minus 2x plus 4 equals 0. So here's the thing. If you tried to solve this problem using factoring, it is not going to work, which means we are going to solve it using the quadratic formula. You could just solve the problem as is, but again, that negative out front, not really a huge fan. So because this problem is equal to 0, I can go ahead and divide everything by a -1. That's going to turn it into a positive 3x squared, a positive 2x, and a -4. This is my A, my B, and my C. Using the quadratic formula from the previous slide, I'm going to do -b plus or minus the square root of b squared minus 4ac all over 2a. Simplify, so -2 plus or minus under the radical. 2 squared is 4. -4 times 3 times -4. A negative times a negative is going to give you a positive. 4 times 3 times 4 is a positive 48. 48 plus 4 is 52. So that's going to be under my radical, 52. All over 6. 52 is a pretty large number, so you're going to need to simplify that. So find the biggest perfect square in 52, which is 4, and it goes in 13 times. That's going to give you that the square root of 4 is equal to 2. And your final answer should always be reduced. And in order to reduce your final answers, you have to be able to reduce all 3 outside numbers at once. Turns out you can divide all of those by 2, which is going to give you a -1, plus or minus 1, leave the 13 alone, all divided by 3. And as a little point here, this one has to be there, whereas this one is optional. So just make sure that you are aware of that. Here on the last two problems, so this is asking you to solve the equation and check your solutions. So you have square roots. You don't want there to be square roots, so you eventually have to get rid of them. In this problem here, we're going to start by getting the square root by itself, which we're going to do by dividing by 8. When you divide by 8, you're getting the square root of n minus 2 is equal to negative 2. A couple of different ways to go from here. The square root of something cannot be negative. So at this point, I'm kind of aware of the fact that there should not be a solution. But let's say that you're not aware that there should not be a solution. The way that you get rid of a square root is to square both sides. When you square a square root, it cancels. When you square negative 2, you get 4. When you add the 2, you get n equals 6. And this is just n potentially equals 6. Again, notice in the directions, it's telling you to check your answers. So what happens if you actually check your answers? Well, you would multiply 8 times the square root of 6 minus 2. That would be 8 times the square root of 4. The square root of 4 is just a positive 2, which means that you would get a positive 16. A positive 16 is not equal to a negative 16. So because the answer that you found didn't work, we're going to say that this problem has no solution. So again, you could have realized that from this step here, the fact that a square root cannot be negative. If you didn't realize it, then just make sure that you check your answers. Things are a little bit nicer in this final problem. The way that you get rid of radicals is to square both sides. That's going to give you just a 2v on the left. That's going to give you a 3v minus 1 on the right. Subtract 3v. Negative v equals negative 1. If you go ahead and divide both sides by a negative, that's going to give you an answer of v equals 1. And if you go ahead and check v equals 1 in the original problem, you find that it is in fact going to work. So checking solutions is never a bad idea. So I strongly recommend it if you have the opportunity. And then finally, there was one problem that we skipped, number 31. So I'm going to go ahead and try to see if I can put that here right now. So going back to number 31, the first thing you notice is that it is not equal to 0. So I'm going to go ahead and recommend that you do change that. So 14k squared plus 13k, add the 3 is equal to 0. So again, you could either do this using the quadratic formula or using factoring. If you're going to use factoring, it's the AC method. So you would multiply 4 times 3, which would give you 12. You'd be looking for two numbers that multiply to be 12 and add up to be 13. So that's only going to work if you use 1 and 12. You're going to take that 1 and 12 and you're going to split up the middle term. So 4k squared plus 1k plus 12k plus 3 equals 0. Do your grouping. Take a k out of the first pair. Take a 3 out of the second pair. You should get that repeat factor, 4k plus 1, k plus 3 equal to 0. And then again, because the problem is asking you to solve, you're going to set each parentheses equal to 0. And you're going to get final answers of -3 and -1/4. Sorry there for a little bit of out of order, but that completes this video. So again, you can go back and watch it as many times as you want. And the techniques found in this PowerPoint really are pretty important. So I would strongly recommend that you go back and look at that as many times as you can. Thanks.